So in this video we're going to look at how to form a quadratic equation with related roots. We should already know at this point that alpha and beta are what we call the roots for our quadratic, and we know that the sum of the roots are related to its coefficients. So alpha plus beta would be minus b over a, the product of the roots would be c over a. We can form a new quadratic using the fact that any quadratic would be x squared minus the sum of the roots times by x plus the product of the roots. So we're going to do x squared minus the new sum plus the new product, and you'll see what I mean when we see example 1. So this potentially could be like an exam style question, like you're given a quadratic x squared minus 6x plus 18 equal to 0, so clearly we're thinking about the roots, like when does this equal 0, and first of all just write down the values of alpha plus beta and alpha beta. You do not want to actually solve the quadratic, like you're not being asked to solve it, we don't care what the actual roots are, we just want to find from this what would the sum of the roots be, what would the product of the roots be. Okay, so all we need to do is say, well, alpha plus beta is minus b over a, so for our quadratic it would be minus 6 divided by a, which is 1. So we know that the sum of our roots would be 6, and the product of our roots is c over a, which is 18 divided by 1, also known as 18. Okay, so the next part of the question says form a quadratic with integer coefficients, so be careful. Easy mark to lose here, like we need to get whole numbers, integer, don't forget it's just a whole number coefficient, and the roots of the quadratic are alpha squared and beta squared. Now the way that you want to approach this is, whatever the related roots are in the question, we need to figure out, well, what's our new sum and our new product. So the new sum for these new roots, alpha squared and beta squared, would be alpha squared plus beta squared. So whatever the roots it mentions in the question, add them together to form your new sum. Now we've seen this already, alpha squared plus beta squared we should know is alpha plus beta squared minus 2 alpha beta. So because we've written it in terms of the sum and the product, we can actually evaluate what this is. Okay, alpha plus beta squared would be 6 squared minus 2 lots of alpha beta, so minus 2 lots of 18. Okay, so that would give us 6 squared 36 minus 2 times 18 minus 36. We actually get 0 for our sum. Okay, we need a new product, and what we mean by product, well, if the roots are alpha squared and beta squared, we multiply them together, so alpha squared beta squared would be the product of our new roots, which clearly we can write as alpha beta squared, and in this case that would be 18 squared, which would be 324. So form a quadratic with integer coefficients with roots alpha squared and beta squared. So now we can form our quadratic, so it would be x squared minus the sum, which is 0 times by x, obviously do not leave it like this, plus the new product, which would be plus 324. So our quadratic would be x squared plus 324. And this quadratic would have roots alpha squared and beta squared. So whatever the original quadratic was, their roots are alpha and beta. This quadratic's roots are alpha squared and beta squared. Okay. It says hence find the values of alpha squared and beta squared. So hence we would clearly want to use our previous answer. Now at this point we actually do, up until this point in the question we didn't care about what the roots were, we cared about what the sum was, what the product was, what the new sum, what the new product, but now we want to find the roots, and we want to find the values of alpha squared and beta squared. Now if you think about it, alpha squared and beta squared are the roots of this new quadratic. So if you want the roots of the quadratic, this is the point where you solve the quadratic. X squared would equal minus 224. Clearly we're going to get complex roots, so plus or minus the square root of the negative think about how surds work. Write the minus outside, so a root times by a root. Now we know the square root of minus 1 is I. We know the square root of 324 actually is 18. If you didn't know it, you could just square root, but you get 18. I. Okay, so these are our roots, 18i and minus 18i. So alpha would equal minus 18i, beta would equal 18i. Or you could put them either way around, it doesn't matter which one's which. Okay. Oh, sorry, alpha squared. But they represent alpha squared and beta squared. So if you wanted to know what the original values were, which we don't, but if you did want to know what the original values were, you could then square root. And then that would give you these roots. Okay. You might, if you wanted to, you might actually want to just figure out what those roots are. Should we do that just quickly for a second? So if we were trying to find the roots of this quadratic, they're going to be complex. You use the quadratic formula, and we would get, it would be 6 plus or minus the square root of 36 minus 4 times 1 times 18 all divided by 2. Okay, so I've done the working out. You'd end up with alpha and beta. The original roots would be 3 plus or minus 3i, and alpha squared would be plus or minus, alpha squared and beta squared would be plus or minus 18i. So these roots are the roots for that quadratic, and these roots are the roots for this quadratic. But the whole point of this topic is most of the time we don't really care about what the original roots are. It's all about like relating the roots together to form a new quadratic. Like most exam questions would be just like messing about with expressions in terms of alpha plus beta and alpha beta. And then the next question that we'll try, we won't actually care about what the original roots are, which is why this topic is so important. We can form a new quadratic just using the relations between the roots. Example 2, we're given the quadratic 2x squared minus x plus 4 equal to 0. Again, we're thinking about the roots. And we're aiming to form a new quadratic with related roots. Okay, first of all, we just want to write down what alpha plus beta is. So alpha plus beta would be minus b over a, so minus 1 over 2. 1 over 2. Obviously, just take your time. You don't want to mess up the first step, because obviously all your answers will be wrong. If you get these 2 bits wrong, it affects every answer that we're about to do. Alpha beta would be c over a, so 4 over 2, which is 2. Okay, now we get a show question, which is going to help us with the next part. So we want to show that 1 over alpha plus 1 over beta is equal to a quarter. So clearly to show this, we're thinking, well, can we get alpha plus beta? Can we get alpha beta? We need a common denominator, so we can add these 2 fractions together. They're going to need to be both over alpha beta. So we're going to multiply this one by beta on the top and on the bottom. And we'll multiply this one by alpha on the top and on the bottom. Once we've got a common denominator, we can add the tops. So alpha plus beta, which is a half, divided by alpha beta, which is 2, which is the quarter that we were asked to show. Okay, now we get to forming the quadratic, so we need to think about what our new sum is. So the new sum, so these are our roots, so 4 over alpha plus 4 over beta. Now if you think about it, we know what 1 over alpha plus 1 over beta is. So if you spotted this, you could take a factor of 4 out. And you've already done a lot of the work for this question, haven't you? 4 lots of 1 over alpha plus 1 over beta, which is a quarter. So 4 lots of a quarter. So we've got our new sum, which is just 1, the new product. Is when we multiply the 2 roots together. So if we multiply these, we've got 4 over alpha multiplied by 4 over beta. And the way that you multiply fractions together, you just multiply the tops, multiply the bottoms, so that would be 16 over alpha beta, which is 16 divided by alpha beta, which is 2, which is 8. Okay, and then once we've got our new sum and our new product, we can form our quadratic. So it'll be x squared minus the sum, which is 1, times x, plus the product, which is 8. And it does say with integer coefficients. Now, I know both of these we've actually got integers straight away. We might do one where we get fractions. If you get fractions, we'll have to just multiply throughout to remove the fractions, but we'll see that when we do some more questions. Let's try one more. Okay, so example 3. I've cut the middle bits out. It was structured like the same as the other ones, but basically you've got a quadratic, and we're aiming to get a quadratic with these new roots. So the root would be alpha plus 1 over alpha, and the other root would be beta plus 1 over beta. So we start by figuring out what our sum is and our product is for the original quadratic. So the original sum would be minus b, which is minus 7 over a. So we've got 7/5. The product would be c over a, which would be 1 over 5. Okay. Now the key to these questions is to think about the new roots that we've been given. And the new sum would be alpha plus 1 over alpha plus beta plus 1 over beta. And remember, you're always aiming to get in terms of alpha plus beta and alpha beta. Now if we rearrange this, we've just got alpha plus beta plus 1 over alpha and 1 over beta. Now we've seen that on the last example, so I'm going to skip straight to, if we put that over a common denominator, that would just be alpha plus beta over alpha beta. Now we can figure out what the value of the sum of the roots is. So alpha plus beta would be 7 over 5 plus alpha plus beta, which would be 7 over 5. Divided by alpha beta. Now if you're dividing by 1/5, just be careful with your fractions here, obviously use your calculator, but like I probably wouldn't divide by 1/5, like dividing by 1/5 is the same as multiplying by 5. So essentially use your calculator, but you've got 7/5 plus 7/5 times by 5, so 7. And then we can think about that as 35/5 plus 7/5, that'd be 42 over 5. New product. We would have alpha plus 1 over alpha multiplied by beta plus 1 over beta. Be careful as we expand this out, we're going to get alpha beta plus alpha over beta plus beta over alpha, and then plus 1 over, we multiply those two together, the two fractions, multiply the tops, multiply the bottoms. So let's just focus on this middle bit, because we've already got alpha beta and alpha beta, but we need to just rearrange this first, don't we? So that would be alpha beta plus 1 over alpha beta plus, so focus on this common denominator, again would be alpha beta, and this one we're multiplying by alpha on the top and on the bottom, so that would be alpha squared. This one we're multiplying by beta on the top and bottom, so we've got alpha beta plus 1 over alpha beta. When we add the tops, we're going to get alpha squared plus beta squared. Remember, we should remember something about alpha squared plus beta squared. We've seen that before. It's alpha plus beta squared minus 2 alpha beta. So now we've got it in a form which is going to enable us to figure out what the value is. Okay, so we can sub in alpha beta as 1/5 plus 1 over 1/5, also known as 5, plus the sum, which is 7/5 squared minus 2 lots of a fifth, all divided by a fifth. Again, you can think about that as multiplying by 5. Okay, so let me just type this up, see what we get. Okay, so I've ended up with the new product being 13. And then once we've got our new sum and our new product, we can write our new quadratic. So it'd be x squared minus the sum, which would be 42 over 5. X plus the product, which would be 13. And this is where the integer coefficient bit is important, so just multiply everything by 5. And you get 5x squared minus 42x plus 65. You don't want to throw away that last one mark after all your hard work, so just make sure you do get your integer coefficients like this. Alright guys, thank you.